Okay, everyone. Today is the starts the last week of summer school. So thank you guys for participating. Those of you guys who've been here every day, I appreciate you, and you should be doing all right. I'm gonna be getting through the grades this week. I put in a lot of grades this past weekend, so that you should have an idea of what to do. Now, a few points to make. I've been getting questions on is one, everything is due on the 26th. So on the 26th, I believe at 5 p.m., which is next Friday, not this Friday, next Friday, the grade books for summer school close. All right, hold on, I had that wrong. That's this Friday. I don't know why I said next Friday. Yeah, this Friday, the 26th, the gradebook will close. So make sure you have all your assignments, and then as long as you have it in by then, this Friday, I will grade it. All right. So no matter what you got going on, just get the work in by Friday, and you'll be good. See anything else? If you've been having conflicting classes, that's fine. Make sure you just get the work done. That's all that really matters. Warm-ups, again, as long as you get them done, you get points for them. And make sure you guys are doing the Edpuzzle videos, because I have been checking those, and I think people forget about them because they're just links. They're not assignments. Just make sure if you see any Edpuzzle videos, you watch those and answer the questions. All right. All right, so we're going to be talking about heat today, and we're going to be talking about how energy transfers from one place to another. So you should have your notes out too. And your notes should look like this when you open them. It should say heat transfer notes, then conduction, think about it, all that stuff. All right. So this is just kind of see what you guys remember from the year. We're having I see a lot of good answers. I think everybody got number 1 right. And Terrell and Balthazar, you got them all right. So good job. So what type of heat is done by direct touch as conduction? Okay. What type of heat transfer is by heating or cooling of fluids? That's convection. And the heat transfer by waves is radiation. And the type of material that transfers heat the best are solids, particularly metals. All right, you did that, you got them all right. Share your scores. All right, let's just kind of see where we're at. All right, let's see. We're gonna start with a video. This video has addresses some misconceptions we have about heat transfer.
When you touch an object and it feels warm or cold, what is that really telling you about the object? Here I have a metal hard drive and a book, and I'm going to ask people to compare their temperatures. Which one do you think will feel warmer, the book or the hard drive?
The temperatures?
Yeah, tell me if one is hotter or colder, or if they're the same temperature. How do they feel?
This is slightly cooler than this one.
Yeah. Oh, that's warmer. Yeah, way warmer.
Yeah, agreed.
I'd say the hard drive is a lot colder than the book. I don't know, because the book's got more knowledge.
Why do you think that is?
Metal's normally a little bit chillier if you leave it in a colder temperature.
Well, what if I said that they're both at the same temperature? What would you say?
So you're lying.
But really?
I think you're lying, yeah.
Oh, jeez. Well, maybe the way I could prove it is I have an infrared thermometer. What do you think we're going to see?
I think science might be able to answer that, and I'm not a scientist.
Make a prediction for me.
I still think that's cool, though.
Would you bet me money?
I don't because I don't have any cash, so yeah.
Let's measure the temperature of the book.
Okay.
What do you see?
19.0.
Okay. We measure the temperature of that.
19.0. All right, well, now I believe you.
I'm trying to actually figure it out, trying to figure out why they would be the same temperature. They don't feel the same temperature, though.
So why does that feel colder if they're basically the same temperature?
Good one. You got the answer?
Well, I'm coming to you guys for answers.
We're creatives, not intellectuals.
Well, create an answer for me.
I'm not a scientist. Come on, you tell me.
Well, I'll try to answer that question with another little experiment. Here is an aluminium block and
Ooh, nice and cold.
a plastic block.
Yeah.
How do their temperatures compare?
Completely different. Completely different.
It's much colder.
Yeah.
Yeah?
Yeah, this actually feels colder.
Let's take this to the next level. I'm gonna put an ice cube on both plates. What are we gonna see?
Well, I'm guessing it would stay solid on this one and melt on this one.
So it's going to melt on the plastic but stay solid on the aluminium.
Yes, but maybe I'm wrong.
That one will melt more quickly than on the aluminium block.
You would think so. I mean, they're colder.
Yeah, because it's cold.
Let's
And I
actually.
think they're going to go the same.
All right, so we put an ice cube on each of those blocks.
Wow.
What are you seeing?
Well, it is melting a lot quicker on the aluminium.
My God, it's melting.
This is melting quicker than that one, even though this is aluminium, that's plastic.
So which one felt colder?
That
This
one,
one.
How does that make any sense?
I have no idea,
Could aluminium be bad for the environment?
How would aluminium be bad for the environment?
Well, it's thawing out the ice a lot quicker, isn't it?
So you want the answer?
Yes, please, please.
It's about thermal conductivity, right? The rate at which heat is transferred from one object to another. So when you felt these blocks originally, I know this one felt a lot colder.
Yeah.
But you know from the other example we did that they must both be at the same temperature.
True.
Because they've both been outside for a
Yeah.
while. We see that the aluminium block is melting the ice faster than the plastic block because it's conducting the heat to the ice cube faster.
Okay.
With the plastic block, it's a worse thermal conductor, so heat is being transferred less quickly to this ice block, and so it's staying ice.
Okay. I believe you.
Make sense?
Yes, definitely.
You know, in our first example, the hard drive felt colder even though it was at the same temperature roughly as the book. And that's because the aluminium conducts heat away from your hand faster than the book conducts heat away from your hand,
Sure, that seems logical.
which makes the hard drive feel colder,
Yeah.
and the book feel warmer.
Yes.
So when you touch something, you don't actually feel temperature. You feel the rate at which heat is conducted either towards or away from you. Think about this next time you hop out of the shower in winter. It's much nicer to stand on the bath mat than on the tile beside it. Not because the bath mat is warmer, but because it conducts heat less quickly away from you.
All right. So this is a quick little video about conduction and heat transfer, and that's kind of what we're going to be going over today. So when we start with conduction, we're going to start with how heat is transferred through direct contact with objects that are touching. So that's what goes up there first. So here, conduction goes there. All right, that's the definition. Anytime two objects touch, heat is transferred from the hotter object, passes heat to the colder object. So conduction is how heat transfers through objects. It has to be through touching. That's the main thing with conduction, how heat transfers through objects that are touching in direct contact.
Where's the pattern?
Yeah.
Oh, no.
All right, so I'm gonna skip that short rant I normally do about anatomy and how your hand can sense things cold or warm. So the interesting thing here is that feeling that sensation you get of feeling something that's hot or feeling something that's cold is transferring energy between your hand and whatever you're touching. So if you touch if you're sitting on like a metal seat right now, or you touch the stove that's been on, if you touch something hot, it is transferring heat to you. We feel that as hot. If you touch something cold, it is taking energy away from you, and your body senses that sensation as cold. So if you hold an ice cube in your hand, you are putting energy into the ice cube, which is causing it to go from a solid to a liquid, and you feel cold because you're losing energy. All right, so like I said, think about it. Fast transfer of heat into your hand feels hot. Transfer of heat away from your hand feels cold. Balthazar, give me a second. I'll check the link. All right, Balthazar, try it now. Metals are great at doing this, so they are really good at conducting energy to and from places, which is why your pots and pans are made of metal, because it would really be silly if you put a rubber pan or a wooden pan on the stove and you wouldn't get, even if you had the heat on full blast, you'd barely get any heat in the pan. So that's why um, metals are the best conductors. Their particles are closer together, which allows them to transfer heat and energy quicker back and forth. You guys a few seconds to write that down. All right. Anyone need more time on this slide? All right, so here's a short video on what is happening inside the molecules on a rod that's heated up.
Conduction. So here we see two likely lads toasting some marshmallows on an open fire. One of them has chosen a metal rod to put their marshmallow on the end of. The other one chose a glass rod. Which one of them do you think is going to burn their hands on their rod first? Well, let's wait and see. Oh, there we go. We can see it was the guy with the metal rod. Why do we think that was? Well, actually, it's because metals are much better at conducting than glass. Glass still does conduct, just not as well. Let's zoom in and look at the particles in the glass and see how it conducts. So glass is a typical solid in the way it conducts. The particles by the fire start to gain heat from it and start to vibrate much more vigorously. They then collide with the particles next to them, passing on the energy, and slowly down the rows each particles vibrate more and more vigorously, passing on heat to the next one through collisions. So it progresses slowly through the glass. This is how conduction happens in most normal solids, and is why solids are so good at conducting, because the particles are so close together that they collide very often. If you imagine it with a liquid or with a gas, the particles are quite far apart, so they do still conduct, they can still collide, it's just not going to happen very often. Right, now let's look at the metal and see why metals are such amazing conductors. If we look at the metal, we see there's still the same process happening as in the glass. The atoms near the fire are gaining heat and vibrating and colliding with the ones next to it. But there's an extra thing happening inside of metals. There's all these tiny little electrons whizzing around. They're called free delocalized electrons. They can bump into all the ions throughout the metal, so they can gain heat from the hot end and race straight down and bump into an atom at the cold end, therefore spreading the heat through the metal much, much quicker. This is why metals are so amazing at conducting. So, what's the key information to remember from this? Well, the key bit of information to remember is that conduction is the transfer of heat via particles colliding with each other. Solids are the best at conducting because the particles are so close together. Liquids would be the next best, but they're pretty rubbish, and gases would be awful because the particles are so far apart they don't collide very often. Also, metals are the best of all solids at conducting because they've got free delocalized electrons which can transfer heat from one end to the other very, very quickly.
Okay. So at the end there, make sure that you know gases are terrible, molecules too far apart. Liquids are iffy at it, but metals are the best at conducting heat. Convection is how heat passes through fluids, and a fluid can be gases or liquids. So that could be water or it could be air, stuff like that. So a fluid is anything that has loosely moving molecules that can move easily from one place to another. Liquids and gases act like fluids. So it is summertime, it's hot out. So when you go to a swimming pool at some point, you'll notice that the bottom of the water is a lot colder than the top of the water. And that's because right there, you'll see a swimming pool. When the sunlight comes in from the top and warms and it goes the sunlight penetrates through all the way to the bottom. It heats the water at the bottom of the pool where the contact between the solid and the liquid is made. And then that starts to heat it up. So hot fluids or liquids rise. So it'll start to become less dense because the particles will be moving faster. And then that water will rise to the top. The water at the top is losing energy and will start to fall. And it creates this little current called a convection current. This works the same way with air. It has a lot to do with how tornadoes work and hurricanes as well, but we won't get into that because that's a longer topic. So the important property is that gases and fluids rise when they are heated. Hot fluid becomes less dense and rises up. Colder fluid becomes more dense and sinks. That's something we covered in the beginning of class 2 is less dense things float, more dense things sink. You guys probably another 30 seconds, minute, copy that down. All right.
Convection. So, we've looked at conduction and we found that both liquids and gases are rubbish at it. But heat can transfer through them fairly easily. And the way it does this is by convection. Convection occurs only in fluids. Now, by fluid, we just mean a liquid or a gas, something that can flow. And the way it happens is always the same. So, let's look at the gas particles in this room. They all have roughly the same energy, which we can see because they're all moving about the same speed. So let's put a fire in the room. Okay, now the particles by the fire start to gain energy from it and they start to move faster. And because they're moving faster, they spread out. So that bit of fluid becomes less dense. And because it's less dense, it rises. Now, when those particles rise, they can't leave nothing behind. So the cooler air or fluid moves in to replace them. But now this cooler fluid is by the fire. So these particles start to gain energy. And this bit of fluid then becomes less dense than the fluid above it. And it rises, pushing the other particles back round. These are now back by the fire. So guess what? They're going to gain energy. They're going to get even hotter. They're going to become even less dense. They're then going to rise. This is going to happen over and over again, forming a convection current. And that is how heat transfers through fluids, liquids and gases. So, what are the key points here? Well, the key points are that in convection, fluid near the heat source gains energy, becomes less dense and rises, being replaced by cooler fluid, which then in turn gains energy, becomes less dense and rises, forming a convection current, which then heats the fluid completely.
Okay. Next up is radiation. Radiation is how heat moves to places where there are no molecules. Mainly, this is like outer space. So radiation is the only one that doesn't need what's called a medium to be transferred. A medium is just, you can think of it like stuff. So a medium is, in a solid, is like the metal. It's the particles that are packed closely together that can transfer energy to and from each other easily. In a liquid, it's the water molecules that are floating around. It's a physical property where energy can be transferred through. But even air, the air particles have either molecules and atoms in the air that can transfer energy to each other when they bump into each other. However, in a vacuum, something like outer space, where there is no air particles, heat energy can't travel there. So it needs to go through radiation, which is how it moves where there are no molecules. And this is through electromagnetic radiation or energy. That's something we talked about too with different light spectrums and different colors and the whole electromagnetic spectrum from radio waves to infrared, visible light, ultraviolet, gamma, X-rays, stuff like that. So that moves in without using a medium. Radiation is heat moving in waves. Okay, it does not need molecules to pass the energy along. And thank God this is true, because if that wasn't true, then our planet wouldn't exist. Because the heat from the sun could not travel through space to get to us, and we kind of need heat to survive as humans. So that's the basis of radiation. You guys a few more minutes to copy that down.
Heat
Here's a
can be
video.
transferred from place to place by conduction, convection, and radiation. Today, though, we'll be focusing on radiation. All objects emit and absorb infrared radiation. Even we do, just a very low amount, but it can still be picked up by thermal imaging cameras that detect the infrared radiation and convert it to visible light. The hotter an object is, the more radiation it emits. Some of it even becomes visible light that we can see. Infrared radiation is a type of electromagnetic radiation which has a lower frequency than light and involves waves rather than particles. This means that, unlike conduction and convection, radiation can even pass through the vacuum of space. This is why we can still feel the heat from the sun even though it's 150 million kilometers away from the Earth.
All right. So that's kind of like what we just talked about. Even though it's very, very far away, you can still feel the heat from the sun because it's traveling through space in a vacuum using radiation. That would also be the same thing as like if you're standing by a fire. That's the kind of heat you feel when if you hold your hand over the stovetop. The heat is transferring through radiation to get to you. All right, so these are kind of what your notes should look like. You should have this top part in. A lot of it's just like one words in the reds. Here's convection. Heat passes through fluids. Radiation is heat moving in places where there are no molecules. All right, so let's do a little check. See how we did. All right, guys, no pressure, but no one's missed a question yet. Good work, everybody. Everybody who's completed it has a perfect score. Keep up the good work. All right. Excellent work, everybody. 100 out of 100. Everyone got a perfect score. Mine says 0 because I haven't answered them yet. But we'll run through really quick because you guys understand this stuff. So direct contact and touch is conduction. What type of heat transfer energy is being transferred through the heating and cooling of fluids? That is convection. Energy in waves is radiation. And solids, the best. The best solid to do that is a metal. That might be something you need to know for the end of the week. A metal is the best kind of solid in order to transfer heat energy. All right, so that's the end of the notes. Good work today, all you guys. So again, if you need the notes, they're going to be on Schoology right here, heat transfer notes. The link that's in here will take you to a self-paced nearpod that you can go at your own rate and finish on your own. So if you need more time on these slides, more than I went through, that's where you do it. Here's the warm-up for today. I fixed the link, so it should be good to go if you haven't done it yet. When you are done with this, make sure you hit submit in your assignment. So go in there and hit submit so that it sends me the assignment and tells me that you're done. All right, so that's all I got for you guys today. Here's how your notes should look, all filled out. All right, so use the remaining time to turn in your assignment. Oh, I didn't show that. Turn in your assignment and ask me any questions you might need. So again, this is how your notes should look. Sorry, I forgot to hit the share button. Okay, so yeah, anything you guys need, let me know. Use this time to make sure you hit that submit button so you can turn it in and you don't have to worry about turning it in later this week. And I'll get a grade for it probably by the end of today. So if you have any questions, feel free to hang around and ask me those questions, and I can try to help you out with them. But that's all I got for you guys today.
Can you show the bottom of the notes?